Hi, in today's video I'm going to discuss the accuracy performance metric. You can find in this card here on the top of the video a playlist on different performance metrics. My name is Felipe, this is the Data Science Bits channel. Please subscribe to the channel and click on the bell button to receive notifications with every video that I post, and follow me on LinkedIn. As in previous videos, let's look at the formulas of the performance metrics and understand it from there. If you haven't watched the confusion matrix video, I will make it available here as a card and also in the end of the video, and also you will find a link in the description of the video. So let's take a look. The accuracy is defined by this formula, and I have highlighted here different terms in different colors, in orange and also in cyan. If you remember, the confusion matrix is represented as this, with actuals on the vertical and predicted in the horizontal. In orange, you identify true negatives and true positives that are highlighted in the same colors in the formula. And also in cyan, outside of the main diagonal, you find the errors that are the false negatives and the false positives. So the accuracy contains all four possibilities: true negatives, true positives, false negatives, and false positives. And of course, it's the true over the overall. That's basically the denominator is the total number of examples in the set where you are measuring your performance metric. So let's say you are measuring the accuracy in the test set. The denominator here has the total number of examples in the test set, because you are summing up all the possibilities, all the true values and all the false values. Now let's compare the accuracy to the other performance metrics that we have talked about in previous videos. For example, the precision, recall, and F1 score. So the recall, also true positive rate or sensitivity, was represented as this. So it's the true positives over true positives plus false negatives. So I'm highlighting here this term. Keep an eye on this type of term in the denominator for all formulas. So the precision is very similar, but you have false positives here in the denominator in the same position. The F1 score, as we already discussed, is a harmonic mean between precision and recall, and you end up with a formula that has the arithmetic mean of false positives and false negatives in the denominator, in the same position that we discussed for precision and for recall. So it means that it considers in equal weights the different errors of your model. Now, the accuracy. It has the errors here, the false negatives and false positives, also considered in equal weights, but the difference here is that you have true negatives in the formula too. This means that we are going to use the accuracy when the negatives have the same importance for you in terms of performance as the positives. So let's consider a model where you are classifying between hot dogs and not hot dogs. This is a very silly example, I know, but it's really clear what we want to achieve. You have photos that are either hot dogs or not hot dogs. So everything else in the world is not hot dog. In this case, your positive class is the hot dog, and all the negatives, you don't care about them. They can be anything in the world. They can be fish, they can be dogs, they can be anything. In this case, you will use either recall or precision or F1. Now imagine that you are classifying between dogs and cats. Okay, so dogs and cats are very specific entities in the world, and you want to get right both cats and dogs. In this case, we are going to use accuracy because you want to classify well both of them. Now let's go to the website to analyze the plots that I prepared as usual. So the website is this one. I will make available a link in the description of the video too. If you scroll down to the accuracy section, you'll find two subsections: balanced distributions and unbalanced distribution. Let's first take a look at balanced distributions. So these are the same usual distributions that I have shown in different videos. And you see here the true positives, true negatives, false negatives. And you see on the right plot the different performance metrics against the threshold. So you keep moving the dotted line from left to right, from 0 to 1, to make the plot on the right for thresholds that vary from 0 to 1. So you see that the recall decreases, the precision increases. This is the trade-off that we have been talking about in different videos. You have the F1 score in magenta here, so it's a mix between the two, and for balanced distributions, when the precision crosses the recall, you also get the maximum of the F1 score. This will not be true for unbalanced distributions. But this is the perfect case where you have balanced distributions. It's about 1000 examples for each distribution. And the accuracy have a similar behavior to the F1 score in this case, but you see that it coincides with precision in this point here at 0. Let's go back to the formula to see why is this. So you see here that when you are at threshold 0, true negatives and false negatives are equal 0, because you are in the tail of the negative distribution, so you don't have either of them. So if you go here in this formula, this is 0, and also false negatives are 0. You get a formula that's exactly the same as the precision, that has only true positives and false positives. Let's take a look now at unbalanced distributions. So now it's very different situation. We have many more of negative examples, negative actuals here. It's about 1000 negative actuals versus 100 actual positives. So let's take a look now at the crossing. So I will zoom in here. You see that, as we already discussed, the F1 score has a max that's in a different position of the crossing here. And in this case, you see that the accuracy maximum happens even later than the F1 score maximum, so it's around here. And you have really to analyze case by case, but the general behavior of the accuracy is something that coincides with precision, increases until a maximum, and then it decreases for higher thresholds. So you'll find a maximum of the accuracy, and that's how you can choose an optimal threshold. So a lesson that you can take from this video is that for each business problem, you need to understand what's really relevant for you, what are your business objectives, where you are gaining more profits, and where you are losing money. And you need to understand what's the best performance metric in this specific case. You should never use all performance metrics at once and try to optimize all of them at once. Each business problem requires a different performance metric. Okay, so that's all for today. I hope you enjoyed the video. I hope these videos are really useful and valuable to you. Please don't forget to subscribe to the channel and also to follow me on LinkedIn. See you in the next video.